recording. Happy Monday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at vmail@yvcc.edu and I will respond as soon as I can. All righty, let's get started here. So today, eventually we're going to take a look at section 10.2, part 2. But first, we have several questions students emailed to me. So we're going to start off with a question from, get down here, from section 10.2, part 1, and this is number 13. Okay, so it says for each equation, write an equivalent quadratic equation, that's the same as a second degree equation, that will be easier to solve. Do not solve the equation. In part A, it says 68x squared plus 51x minus 34 equals 0. And what it has written, it has a box for you to put something in, and then it says x squared plus, it has another box to put something in, x minus 2 equals 0. So what they want us to do is to take this equation and write it like this, filling in the coefficients for the x squared and the x. Well, the clue or the key here is how could we get from there to there? 34 divided by 2 is 17. And if we look at it, we find that 17 goes into 68 4 times. 17 goes into 51 3 times. And 17 goes into minus 34 minus 2 times. So if we took this original equation and divided each term by 17, we would get this. So that first box should be the number 4. The second box should be the number 3. Any questions about that before I go on to part B? All right, let's take a look at part B. This says 1/2 m squared minus 1/5 m minus 1/2 equals 0. And we have a box, and then it says m squared minus a box, m minus 5 equals 0. So we need to take this equation and write it like this. And what we're going to do is we're going to get rid of the fractions. Well, if we look at the equation, the least common denominator of 2, 5, and 2 is 10. And if we multiply both sides by 10, this term will turn into that. So basically, we're going to multiply everybody by 10. 10 times 1/2 x squared would be 5x squared. 10 times minus 1/5 m would be minus 2m. 10 times minus 1/2 would be minus 5. So the numbers that go in the boxes are 5 for the m squared, minus 2 for the m, and we already had the minus 5. So basically, we're clearing the fractions in this equation by multiplying both sides of the equation by the least common denominator. Any questions about that before we go on to another problem? Okay, let's see here. And there. And part 1. Let's see here, number 19. Okay. This is also from section 10.2, part 1, and this is number 19. It says, use the quadratic formula to solve the equation. Enter your answers as a comma-separated list. And the equation is 6x squared plus 0.3x equals 0.08. What we're going to do first of all here, we're going to get this equation in standard form. So I'm going to subtract 0.08 from both sides of the equation. That gives me 6x squared plus 0.3x minus 0.08 equals 0. Next, we're going to clear the decimals. Well, the first term doesn't have any decimals. The second term I'd have to multiply by 10. The third term I'd have to multiply by 100. So I've got to do the same thing to everybody. So I'm going to multiply each term on both sides of the equation by 100. So I've got 100 times 6x squared plus 100 times 0.3x minus 100 times 0.08 equals 0 times 100. So having distributed the 100, now multiply. 100 times 6x squared is 600x squared. 100 times 0.3x would be plus 30x. And minus 100 times 0.8 would be minus 8 equals 0. Okay. Now, we've gotten rid of the decimals, but looking at it, I see if I wanted to, I could take out, what, a 2? So it's like we multiplied by 10 and then divided by 2. Why didn't we just multiply by 5? Well, perhaps it wasn't easy to see. So now I'm going to divide oh, wait a minute, not by 5. I'm going to divide everything by 2. So I get 300x squared plus 15x minus 4 equals 0. Now, all of that put the quadratic equation in standard form. I got rid of the decimals, then I reduced it down. So now I'm going to take this equation, copy that on the next page, and basically start over plugging that into the quadratic formula. Okay, so 300x squared plus 15x minus 4 equals 0. Let's go back and double check. Let's see, I moved that over. That looks right. Multiplied by 100 over 2 places, over 2 over 2, divided by 2. Okay, so now A is 300, B is 15, and C is negative 4. Whoops. Come on, eraser. There we go. All right. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, any questions so far? All right. X equals negative 15 plus or minus the square root of, let's see, I think 15 times 15 is 225, but let's make sure. 15, yeah, 225. And then minus 4 times 300 would be minus 1200 times negative 4 would be 4,800. 2 times 300 is 600. Okay. So then x equals negative 15 plus or minus the square root of, let's see, 4,800 plus 225 is 5,025 all over 600. Okay, well, let's see here. I need to see if I can simplify the square root of 5,025. The first thing I think I would do is see if by chance 5,025 is a perfect square. So I'm going to take the the square root of 5,025. It's 70.88. So it's not a perfect square. So let's see what we can do with 5,025. Well, it ends in a 5, so I can see that 5 goes in. In fact, can you see that 25 would go in evenly? So that would give me, let's see, 25 times what? Well, let's take 5,025 divided by 25, and I get 201. So then the question is, can I take 201 and factor it down and get any perfect square factors out of that? Well, 201 isn't even, so 2 doesn't go in. But remember how you tell if 3 goes into a number? If you add up the digits, if the sum of the digits is divisible by 3, the number is divisible by 3. Well, 2 plus 0 plus 1 is 3. 3 goes into 3. So basically, I could factor this down to 25 times 3 times, let's see, 201 divided by 3 is 67. 67 is prime. So basically, let's go back up here. That would become 5 square roots of 201, okay? That's as much as I can simplify it. So now I get x equals negative 15 plus or minus 5 square roots of 201 all over 600. Now, this is correct, but we can reduce it down further because this number, and this number are all divisible by a 5. So what I'm going to do now, I'm going to split this up, and write it as x equals negative 15 over 600 plus or minus 5 square roots of 201 over 600. And I'm going to reduce both of them down by 5. So this would be what? Negative 3 over 120 plus or minus the square root of 201 over 100. Oops. Some days my eraser just, there we go, doesn't want to work. Over 120. And in fact, I suppose I could put that back together. 201, slow down. There we go. 201 over 120. So this is a correct answer. This is more in doing with what they tend to do, putting it all as a single fraction. All right. That had quite a bit going on there, didn't it? Any questions about any of the steps I did there?
So the one on the bottom, the x plus or x equals negative 3 plus or minus the square root of 201 over 120, is that what you would enter into WebAssign?
Oh, yes, except you'd put them separate, the plus and the minus. So in WebAssign, you'd go negative 3 minus the square root of 201 over 120, comma, negative 3 plus the square root of 201 over 120. Now, WebAssign should also accept, if you wrote it this way, let's see, negative 3 over 120 minus the square root of 201 over 120, comma, negative 3 over 120 plus the square root of 201 over 120. In other words, you could leave it as separate fractions or as a package deal. But with WebAssign, again, you'd have to have 2 separate answers, right? Because you can't do the plus or minus in WebAssign.
Gotcha. Thank you.
Yeah. Okay. Let's see. There was one more. It was problem 22. So this, again, is in 10.2, part 1, number 22. It says, use the quadratic formula and a calculator to solve the equation. Round answers to the nearest hundredth. Enter your answers as a comma-separated list. Okay, So our original equation is 49x squared plus 18x minus 90 equals 0. Well, let's see. 9 goes into 18 and into 90, but it doesn't go into 49. 7 goes, I can't do anything to reduce it down. So A is 49, B is 18, C is negative 90. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. That's supposed to be negative 90. Okay, so X is negative 18 plus or minus 18 squared. I think that's 324. Yes, it is 324. Then we've got, let's see, negative 4 or minus 4 times 49, which is negative 196, times negative 90, which is plus 17,640, all over 98. Okay, so X equals negative 18 plus or minus the square root of, let's see, 17,640 plus 324 is 17,964 over 98. Now, again, the first thing I think I would do is find the square root of 17,964 to see if it's a perfect square, but I suspect it isn't, because the hint was it said approximate the solutions to the nearest hundredth. That tells me things aren't going to come out nicely. But let's see here. Yeah, it's like 134.0298, blah, 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 blah. Okay, now, on the last problem, I took the quantity that was inside of the radical and I simplified it down to get an exact solution. This problem, they're telling us that they just want the decimal answers. So there's really no need for me to take 17,964 and see if I can, for instance, I can take a 4 out of it and somehow reduce it down. I'm going to go straight to the calculator. So I'm going to use X equals negative 18 plus, let's see, 17,964, square root of 17,964 all over 98, and X equals negative 18 minus the square root of 17,964 all over 98. Okay, and this is where I'm going to get my answers to the nearest hundredth. All right, now I need parentheses around the whole numerator and around the radicand. So I'm going to go parentheses negative 18 plus the square root parentheses 17,964, close parentheses, close the entire numerator in parentheses, divided by 98. And I'm coming up with 1.183978, et cetera, et cetera. Rounding to 2 places, I would get 1.18 because the 3 in the thousandth place would round down. Okay. Now, negative 18 and parentheses negative 18 minus the square root of 17,964, close it up, close up the whole thing, divided by 98, and I get negative 1.551324, etc., which would round off to negative 1.55 because the 1 would round down. So there are the 2 approximate answers to the nearest hundredth. Any questions about that problem? Okay, then we're going to go on to the last part of section 10.2. So this is 10.2 part 2, and we're going to be looking at some application problems. Okay, now let's see here. one of the things I want to talk about, and let's review it quickly, something called the Pythagorean Theorem that says when you have a right triangle, that is a triangle with one right angle, the longest side is called the hypotenuse, and we also label that side C. The other two sides are called the legs, and we label them A and B. For a right triangle, the following relationship is true. The length of A squared plus the length of B squared equals the length of C squared. So again, this is the Pythagorean theorem. We're going to be using that on some of these problems, especially this one. Okay, now, here's the problem. It says crosswalks. Refer to the illustration below. So let me draw a picture of what's going on here. Let's see. And we've got these crosswalks. And there. Okay, this is Nordstrom's, or Nordstrom, S-T-R-O-M. And this is Best Buy. And this is Main Street. And this is First Avenue. Okay. Now, refer to the illustration below. Instead of using the Main Street and First Avenue crosswalks, in other words, instead of going here and then here to get from Nordstrom's to Best Buy, a shopper uses the diagonal crosswalk to walk 97 feet directly from one corner to the other. So instead of going from here to here and then from here to here, they're going to use this diagonal crosswalk. Okay, and we know that that is 97 feet long. If the length of Main Street crosswalk is 7 feet longer than the First Avenue crosswalk, how much walking does the shopper save by using the diagonal crosswalk? Okay, so the Main Street crosswalk is 7 feet longer than the First Street. So if we call the First Street X, this would be X plus 7. So we want to know how much distance they save by walking the 97 feet instead of by walking this piece plus this piece. All right, well, what this all boils down to is we've got a right triangle where this side is X, this side is X plus 7, and this side is 97 feet. Okay? I'm going to recopy that. Well, actually, let's do this. Let's call this A and this B and this C. Okay? So using A squared plus B squared equals C squared, we get the following. We get A plus, or X plus 7 squared plus X squared equals 97 squared. Any questions how I got there? All right, I'm going to take this, recopy it on the next page so I have lots of room to work it out. So X plus 7 squared plus X squared equals 97 squared. Let's check. Yeah, okay, so here we go. X plus 7 squared is X plus 7 times X plus 7. X squared is X squared, and 97 times 97, hang on here, 97 times 97 is 9,409. The problems in this section of the book have big numbers. It's a good thing we can use a calculator. So now I've got X squared plus 7X plus 7X plus 49 plus X squared equals 9,409. Combining like terms, 2x squared plus 14x plus 49 equals 9,409. My next move, I'm going to subtract 9,409 from both sides of the equation, and I get 2x squared plus 14x. Let's see here. If I take 49 minus 9,409, I get minus 9360 equals 0. Okay, so I've got my quadratic equation. I've got it in standard form. I could reduce it down. I could take a 2 out, so I'll divide everybody by 2, and I get x squared plus 7x minus, let's see here, 9360 divided by 2 is 4680 equals 0. Okay, now I'm going to go to the next screen and I'm going to recopy that. X squared plus 7x minus 4680 equals 0. And now I'm ready to put it into the quadratic formula. A is 1, B is 7, C is negative 4680. Any questions before I go on? Do you need to look at any of the previous pages? Okay. X is negative B plus or minus the square root of B squared minus 4AC all over 2A. X is negative 7 plus or minus the square root of 49. Now, let's see, what have I got here? I've got negative 4 times 1, which would be negative 4, and then times negative 4680 comes out to 18,720. All of that over 2. X equals negative 7 plus or minus the square root of, let's see, 18,720 plus 49 would be 18,769 all over 2. So now the directions didn't say anything about decimal approximations. So I'm hoping that the square root of 18,769 comes out nicely. And let's see if it does. It does. It comes out to 137. So x equals negative 7 plus or minus 137 over 2. Okay. So that means x equals negative 7 plus 137 over 2. X equals negative 7 minus 137 over 2. Well, on top, negative 7 plus 137 would be 130, and that over 2 would be 65. On the bottom, negative 7 minus 137 would be negative 144 over 2, which is negative, what, 72. So x either equals 65 or negative 72. Any questions before we go back to the beginning to plug these in? Now, x is a distance. X plus 7 is a distance. A distance can't be negative. So for this problem, even though negative 72 is a solution to this equation, it doesn't fit the model of the problem. So it's got to be x is 65. So if that's true, this is 65 feet. And this would be what? 65 plus 7 is 72 feet. Now, the original question was, how many feet do you save by walking this distance as opposed to those two? 72 plus 65 is 137, okay? Minus 97 is what, 40? So basically, by walking across the diagonal crosswalk, you walk 40 feet less than by walking on this crosswalk and that crosswalk. Okay, and I know you're thinking, I'd rather just walk the extra 40 feet than have to figure this all out using math. But that's not the point. The point is, can you do it? Can you deal with the situation? All right. Any questions on that before we go on to another example? Okay. This says, right triangles, the hypotenuse of a right triangle is 2.5 units long. The longer leg is 1.7 units longer than the shorter leg. Find the lengths of the legs of the triangle. This is basically the same problem, but without an elaborate description of streets and crosswalks. It's just telling us we've got this triangle. It's a right triangle. The hypotenuse is 2.5 units. The longer leg is 1.7 units longer than the shorter leg. So if we call this x units, this is going to be x plus 1.7 units, okay? The hypotenuse is 2.5 units. The longer leg is 1.7 units longer than the shorter leg, okay? Find the lengths of the legs of the triangle. So this is C. A and B are the two legs. It doesn't matter which leg we call A and which leg we call B. So using the fact that A squared plus B squared equals C squared, we've got x plus 1.7, the quantity squared, plus x squared equals 2.5 squared. Any questions? Alrighty. This is x plus 1.7 times x plus 1.7 plus x squared is x squared. 2.5 squared is 6.25. So foiling, we get x squared plus 1.7x plus 1.7x plus, I think 1.7 times 1.7 is 2.89. Yep, it is. 2.89 plus x squared equals 6.25. Okay, combining like terms, we get 2x squared plus 1.7x plus 1.7x would be 3.4x plus 2.89 equals 6.25. Next, we're going to subtract 6.25 from both sides of the equation. 2x squared plus 3.4x. Let's see, 2.89. Let's see here. Minus 6.25 is minus 3.36 equals 0. Okay. So let's see here. Now, let me throw this out as an option. Typically, we've been getting rid of the decimals. Do you want to live with the decimals? We're going to use a calculator. Do you want to just live with them, or do you want to get rid of them? It's up to you. Nobody wants to get involved? Okay.
Say it again.
Do you want to get rid of the decimals or live with them?
Live with them.
Okay, let's do that. A is 2. B is, we may regret it, but at least now we'll find out. And C is negative 3.36. Okay. So that means x equals negative 3.4 plus or minus the square root of 3.4, the quantity squared, minus 4 times 2 times negative 3.36, all over 2 times 2. Okay. So that's going to mean x is negative 3.4 plus or minus, let's see, 3.4 squared. 3.4 squared is 11.56. So 11.56. And then I've got minus 4 times 2, which would be minus 8. Times minus 3.36. I'm getting 26.88 plus 26.88 all over 2 times 2, which is 4. Okay, so x is negative 3.4 plus or minus the square root of, let's see, 11 No, hang on. 11.56 plus 26.88 is 38.44. All of that over 4. Okay. Let's see. I wonder if that is, oh, that's a perfect square. How nice. So I get negative 3.4 plus or minus 6.2 over 4. Because the square root of 38.44 is 6.2. So now I've got x is negative 3.4 plus 6.2 all over 4, or x is negative 3.4 minus 6.2 all over 4. Now, let's see, negative 3.4 plus 6.2 is 2.8 over 4, which would be 0.7. Negative 3.4 minus 6.2 would be make negative 9.6 over 4, which is negative 2.4. So we're getting x is 0.7 and x is negative 2.4. However, once again, in this situation, we're dealing with lengths or distances, so we couldn't use the negative answer. Now, be careful. Just because these problems, in fact, many of the problems in this section, you get a positive and a negative answer and you throw out the negative answer because we're looking for a distance. That doesn't mean you always throw out the negative answer. You've got to consider the answers with the actual problem. You can't have a negative distance. You can't have a negative time. Okay. All right. If x is 0.7, then back up here, let's see. X would be 0.7 units and x plus 1.7 would be 2.4 units. So the answer 0.7 units, 2.4 units. All righty. Any questions about that one? We're going to take a look at one now that's not a triangle. This is a rectangle. So the Pythagorean theorem will not be used on this problem. It says the largest permanent movie screen is in the Panasonic IMAX theater at Darling Harbour, Sydney, Australia. The rectangular screen has an area of 11,349 square feet. So we've got this rectangular screen and the area equals 11,349 square feet. Find the dimensions of the screen if it is 20 feet longer than it is wide. So let's say the width is x, the length is going to be x plus 20 feet, okay? So the length is 20 feet longer than the width. The area of a rectangle is the length times the width. So the area, 11,349, equals the length, x plus 20, times the width, which is x. Any questions how I got that? Okay. So then 11,349 equals x squared plus 20x. We'll subtract 11,349 from both sides. 0 equals x squared plus 20x, minus 11,349. Okay, so A is 1, B is 20, C is negative 11,349. I told you this section had big numbers. X is negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative 20 plus or minus the square root of 400. Minus 4 times 1 is minus 4 or negative 4. So I've got negative 4 times negative 11,349 And I'm coming up with plus 45,396. All of that over 2. Let's go to the next page. X equals negative 20 plus or minus the square root of, let's see, 45,396 plus 400 is 45,796. Okay. And let's see, if we take the square root of that, we get 214 all over 2. So then we've got x equals negative 20 plus 214 over 2. Let's see, which is 194 over 2, which is 97, or x is negative 20 minus 214 over 2, which is negative 2, oops, negative 234 over 2. You know what? We're looking for lengths and distances, aren't we? So I don't even need to finish that because it's going to be negative. So x is 97. So this is 97 feet. And this would be what? 97 plus 20 would be 117 feet. So the width is 97 feet and the length is 117 feet. All righty. Any questions there? Okay. I've got one more problem to look at with you. You're going to love this one. Okay. It says picture framing. The matting around the picture has a uniform width. How wide is the matting if its area equals the area of the picture, round to the nearest hundredth of an inch? Okay, so let's draw the picture. So we've got this picture frame. And inside of it, and there's a sailboat in there, and some trees, etc., etc. Okay, now it tells us that this distance from here to here is 5 inches, and this distance from here to here is 4 inches. And let's see what else it says. Okay, the matting around the picture has a uniform width. So this distance right here, let's do that in red, this distance and this distance and this distance and this distance, they're all the same, okay? The matting around the frame, let's call that X. How wide is the matting if the area of the matting equals the area of the picture, round to the nearest hundredth of an inch? Okay, can you see that the dimensions of the picture are 5 inches by 4 inches, which would be 20 square inches? Is everybody clear on that? Okay, now it also says the area of the matting equals the area of the picture. So the picture is 20 square inches. The matting is also 20 square inches. Okay. So in fact, the area of the picture plus the area of the matting would equal, so total would equal 40 square inches. So that means this whole thing has an area of 40 square inches. You see where I got that? The picture is 20 square inches. The matting was the same area, so it's 20 square inches. 20 plus 20 is 40 square inches. All right, now we know the total area. So total area. How about let's find the dimensions of the whole outer thing. From here to here, well, we know actually, let's do this over on the other side where it's already marked. From here to here, we know that this little piece is 4 inches, right? And isn't this little piece right here X, and this little piece is X? So that whole thing would be 2X plus 4. Any question where I got that? Okay, how about this whole piece? From here to here is 5 inches. This is X and this is X. So that whole thing is 2, well, I can't write it on there. I'll write it down here. It's 2X plus 5. Okay, so the dimensions of the outer part are 2X plus 4 times 2X plus 5. Well, area equals length times width. So 40 equals 2X plus 4 times 2X plus 5. Is anybody confused about where I got the 2X? Okay, good. So 40 equals 4X squared plus 10X plus 8X plus 20. I'm going to take that to the next page. 40 equals 4X squared plus 18X plus 20. I think I got that copied right. Subtract 40 from both sides. 0 equals 4X squared plus 18X minus 20. I'm going to divide everybody by 2. 0 equals 2X squared plus 9X minus 10. A equals 2, B equals 9, C equals negative 10, X equals negative B, plus or minus the square root of B squared, minus 4AC all over 2A. X equals negative 9, plus or minus the square root of 81, but plus 80 all over 4. X equals negative 9 plus or minus the square root of 161 all over 4. Since it said rounding, that tells me it's not going to come out exact. So let's figure out what the two possible answers are going to be. So parentheses, negative 9 plus the square root of 161. Close up the radical, close up the entire numerator divided by 4, and I get 0.922. It said to the nearest hundredth, so that would be 0.92 inches. Well, negative 9 minus the square root of 161 is going to be negative, isn't it? So that one's not going to work. So 0.92 inches. So back here, X is 0.92 inches. So that matting that goes around the picture of the frame is approximately 0.92 inches all the way around. Okay. Tomorrow, we're going to be doing some graphing. So you might want to get hold of some graph paper if you don't have any at the moment. And anyway, I'll be back this afternoon at 1:15 with an office hour. If you have any other questions. So let me find the elusive mouse. There it is. And I'll stop this recording.